working as an assistant professor. I did my PhD in 2015, then I did postdoc for 4 years, and I joined IST in 2017. My area of interest is computer architecture, memory system design, and embedded systems. Okay, so I have been given the responsibility of teaching you the computer organization and architecture course. So, do you have any idea what is computer organization and architecture? What's the difference between architecture and organization? Any clue? What is the difference between computer architecture and organization? What does architecture and organization refers to? Anybody? You may have studied, some of you may have studied this course in your undergrad. Any idea?
Architecture basically deals with the basic components in the processor design, like registers.
It refers to the components. The components refers to the organization, not in architecture. There is a difference between architecture and organization. So actually, architecture. What's in architecture? Architecture refers to the attributes. Architecture refers to the attributes which are visible to the programmer. What attributes are visible to the programmer? What are the different attributes that are visible?
Data bus की width कितनी है? Address bus की width कितनी
What
है?
are the attributes that are visible to the programmer? It's not about the data bus. The data bus refers to the organization, not the architecture.
So, for instance, the memory size, etc.
No, it's also not visible.
Processor capability.
No, it's not even visible to the programmer. The things that are visible to the programmer are instruction set architecture. ISA. If you remember ISA, what does ISA stand for? Instruction
set architecture.
Set architecture. Now there are two levels of programmers. Two levels. We have a C program, which is very high level, and then there is an assembly program. So if you have two have different views, there are different levels of abstractions. There are different levels of abstraction. Some people work at a very high level of abstraction, some people work at a lower level of abstraction. So if we look, now what is an abstraction? First, before there we need to define an abstraction. What is an abstraction? Do you have any idea what's an abstraction?
So it basically hides the exact details of how.
Very good. It hides the details of the system of the components. I will give this with an example. So abstraction is to hide the details of the system and provide an interfaces. Now what are the details? I will give you an example of a car. Now let's assume if you are driving a car. What are the interfaces with which you interface with the car? What are the interfaces? Steering, brake. These are the interfaces with which you interface with the car. These are the interfaces in which you interface with the internal of the car. Now let's see if you are the first gear or second gear. Instead of first gear, you cannot achieve some certain level of speed. Okay, how do you control that? To the interfaces. To the interfaces is the steering. Okay, now there are different views of the. Let's assume if you are in C program, what are the interfaces? What are the interfaces with which you interact with the processor? Let's assume you are programming C. You know obviously. What are the interfaces? You know about C programs, yes?
So functions, data types.
Very good. Functions, data types. So if we say that the interfaces with which you interface with this functions, data types. Functions and data types. So these are the interfaces. Okay, now there are a lot of functions. What kind of functions are there? For instance, if you say, because you don't know what is the size of each data type, maybe an integer is represented by 4 bytes in one architecture, maybe the same integer represented by 8 bytes in another architecture, and maybe it is represented by 2 bytes in another architecture. So now, if it means that now when you are defining an int variable, for instance, int a and b, A and B. So what it means that you are reserving a variable in memory. Okay, now what is the address of that memory? You don't know these details. At which location that variable is stored, you don't know these. So actually, from the architecture, if you look at I mentioned before, instruction set architecture. In instruction set architecture, each processor has different instruction set architecture. There are RISC architecture and sys architecture. So now there are different architectures. In architecture, we have some set of instructions. For instance, add, subtract, multiply, divide, logical shift left, logical shift right. A lot of branch equal, branch not equal. Maybe you have studied this branch equal, branch not equal, and so many. There are a lot of instructions in architecture. Okay, these attributes, these are the attributes which are visible to the programmer or invisible to the programmer. These are visible to the programmer. Now let's do. If we say now I will also make a relationship between the C program and the assembly level program. Now let's assume if we have a simple statement C is equal to A plus B. C is equal to A plus B. So this C is equal to A plus B is actually an operation. It is an operation. If you look at C, C is an operand. That is, we can call it result operand. And then we have an operand, source operand 1 and source operand 2. And now if you look at the plus sign, it means that this is now what? Operation. Now if you look at this high level C statement, C is equal to A plus B at a very high level, these details are extracted from the programmer by the compiler. Now what's the compiler? What's the job of a compiler? Compiler will translate this statement in a C language into machine level instructions or machine level program. Now let's do, if we have to look at this very simple instructions. So one kind of the translation of this into this. Now so let's do. Initially what the compiler will do? Compiler will allocate memory location for the variables A, B and C determined by the data type of. So let's assume if the data type of C is integer, and let's assume that the size of this integer is 4 bytes. Let's assume a scenario. So it means that now the compiler will allocate a memory location for 3 variables A, B and C, and each location will have some address, maybe address ADR address of A, ADR address of B, and ADR address of C. Okay, now if you look at this, so are these details visible to the programmer or invisible to the programmer? Invisible. These are invisible to the programmer. The things that are visible to the programmer, that C program C is equal to A plus B, this is a statement. This is visible to the programmer. Now this is the view of C programmer, not assembly programmer. If you look at the view of the assembly programmer, so maybe if we translate this code, simple snippet of code in assembly, maybe we can have this like this: load R1 address of A. So what is the address of A? The things that is placed on the address of A. Maybe this address, if you look at the hexadecimal address, maybe this address is 0x5432. Maybe this address is 0x6924. Maybe this address is 0x7934. These are different addresses. Now what is the memory? Now if we store the data in memory, so memory has the content of the data and address of the data. Okay, now बेटा इनका अपने लेट नहीं आ रही, ठीक है? Okay, so now, so this is an address. This is the data, actual data. Okay, so now if we say that its So the compiler, now let's if you declare these variables int a, b and c, so with the use of this statement, the compiler will allocate 3 memory locations. This is memory location 1, memory location 2 and memory location 3. Each memory location has an address. This is address of A, address of B and address of C. Okay, now these 3 variables have been allocated by the compiler in the memory. Okay, now if you want to translate this statement, not only this statement, okay, this statement into assembly, so it means load R1 address array. Now we have some processor. Within this processor we have some registers. So let's assume we have a processor architecture in which we have some register R0, R1, R2, R3, R4 and so forth, so on. And let's assume that the contents of these registers are 5, 7, 6, 9 and 3. So load R1 with an address of A, what will happen? That in this case, now address of A, so actually address of A, R1 is loaded with the value of A. Let's assume that the value of A is 35. What will happen? This value of 35 will be loaded in which register? R1. And the old contents of the register will be what? Modified. What will be the new contents? 35. Now we have loaded one of the source operand. One of the source operand. Now if you look at the another source we want to load, so we can load it into another register. Load R2, address of B. So what is the address of B? This. It will point to this location. Address of A, it will point to this location. And it will point to the location in the contents of B of the memory and an address, this particular address. Let's assume the value is 13. So it will be where it will be loaded?
In R2.
R2. So now the contents of R2 will be 13. Now if the contents of R2 are now 13, then okay, now we want to add them. So this is add R3, R1, R2. So this instruction will add the contents of R1 and R2. What is the contents of R1? 35 plus 13. So what's the result now? 48. So where the result will be stored? R3. So what's the new contents now?
48.
48. Now we need to store these contents back to memory. So what should we do now? Store. It depends on the architecture. Now I'm just talking about a very general architecture. Store. Okay, now this is destination. So now destination is memory. So destination is on the left hand side. So store
R4.
address of C. Now in this case, register is your destination. So if you use load and store, destination and source. So in this case, destination is register, destination is register, and now in this case, destination is memory. So the contents of R3 is stored into memory, and this 48 will be written in. And let's assume the old contents is 22, so it will be overwritten, and the new contents will now be 48. Now with this simple illustrating example, we would like to highlight. Now again, architecture. I'm now coming back to the definition. What are the architecture? Architecture refers to the attributes which are visible to the programmer. What are the attributes which are visible to the programmer? Register file. It's visible to the programmer? Yes. What are the other attributes? The instruction set architecture. The type of operations that you can perform. So this refers to the architecture. Now what is organization? Organization means that how different components of the system are interconnected. How different components of the system are interconnect. So if you look within inside a processor, what are different components? Instruction fetch unit. What is instruction fetch unit? It fetches the instruction from memory. Then instruction decode unit. It decodes the instruction, what type of instruction it is, whether it is add instruction, subtract instruction, multiply, divide, and so forth, so on. Okay. Then operand fetch. Then it fetches the operand. Now this operand may lie within a register, or this operand may lie within memory. So whether the operand will lie within a register or a memory depends on the addressing modes. And you have studied these addressing modes. We will also study this addressing mode. Different type of addressing mode are immediate addressing mode, register addressing mode, register indirect addressing mode, stack addressing modes. Okay, so these are the addressing modes that we will study later on. I will give a very quick overview of these addressing modes. Okay, and then instruction execute unit, and then you also need an interface with the memory. So this refers to the organization, in the organization hardware. But the programmer, whether it's C programmer or assembly programmer, does not know how they are connected. How they are connected. C programmer, maybe assembly programmer know the size of the memory. We also know he does it automatically. But if you look at a very high level programmer like C++ programmer or Python programmer or very high level, it does not know the details of the system. He doesn't know that which architecture it is using, whether it is using Intel architecture, whether it is using ARM architecture, or whether it is using other type of architecture. All of these details are hidden from the programmer. Just like when let's say if a driver is driving a car, he does not know the details of the car. He does not know whether it's what's the size of, maybe he knows, maybe what's the size of the engine, what's the fuel injection technology, what's the braking technology. Maybe he just know a little bit high level overview of the system, but he does not know the internal working of that. And he doesn't need to know. How does he interface with the car? Through the interfaces. What are the interfaces? Which are visible. What are the interfaces for a car? Steering, brake, and so if you look at the C programmers, the interfaces are the functions. We also call it application programmer interface. Okay, and with these functions, you actually interface with the system. Now let's assume if we write some function printf. Let's assume printf in C and then say hello world. Can you think what's happening? What's happening? What will happen? This hello world will be printed on the screen. Yes. But it will be on the screen, but if you look in the internal details, actually this information will update the video memory. And if you look at the video memory, so if you look at this screen, that this is complete screens. So it will print this hello world on the current cursor position. Let's assume that the current cursor position is here. Cursor position is here. And it will print hello world here. Okay, now let's assume that this screen is white and the background is black. And this thing. So actually if you look at this screen, so actually this will be some pixels. And if you look at this pixel, so actually if you look at the resolution of the monitor, so it means let's assume it has 1024 rows and let's assume 940 columns. Each of these will be pixel values. And if you look at each pixel value, it has some representation RGB. Yes. Red, green, blue. So let's assume if it is 8-bit, 8-bit and 8-bit. So if it's 8-bit, so the maximum value range from 0 to 255. So if the value is RGB is 255.00, which color is it? Red. And then 0, 255 and 0? Green. And if you have a combination, so it's a combination. Now if you look at this, for every pixel is now represented by 24-bit of data. When it's 24-bit of data, and if you look at this hello world, so actually if you look at here, so it will some pixels will be like this, some pixels will be like this. If you look at each pixel value. Now if you look at this memory, so if it's actually one frame. It is one frame. And if you look the size of the frame for this particular resolution, so the size of the frame will be 1024 multiplied by what?
940.
940 multiplied by what?
24 bits, yes sir.
So actually this is the size of the one frame, and this information will be uploaded in the video memory. Is it visible or invisible? Invisible to whom? Programmer. Now here also comes the role of the operating system, because whenever he is printing maybe his operating system, now if you look at comes the role of the operating system, and operating system is running multiple programs. So actually even if you just it's also switch between records time to different programs, like there are program P1, P2 and P3, and see if it is currently active. So which value will be updated in the video memory? It depends on the current active program. Like which thing? So now all of these details, high level details are hidden from the program. And this video memory, so it means that it's now this kind of information is just only for one frame. For one frame. Now let's assume you have a video and you are running this video. So you will be uploading that frames, and that's the reason that you need compressions. If you are using YouTube video, so you need high quality compression, because if you want to reduce the interconnect on the pressure on the interconnect, that's the reason that YouTube is using a lot of compression techniques. If they want to center it, they compress it, and on the destination end, then there is a decompression, and it decompresses the video. So coming back to the problem, so actually, what is this printf? Printf is an interface. Interface to which what? Interface to the video your display. Interface to the display. And how does it send the data? What are the contents of this video memory? Everything is hidden from the program. Everything is hidden from the program. So now we will also study more kind of things. Like let's assume if you study more in detail, you also study the architecture part. We will also cover the organization part, and we will study each of them in more detail. Okay. Now I will do very fast because your graduate course I will be like teaching very fast. So I already uploaded a lot of lectures. Okay, and these are the lectures for the undergrad. So I already taught undergrad course. Okay, so I will share the link of the Google Drive, okay, in which all the materials are available, and I also share my undergraduate lectures of embedded systems. So if somebody is not like, if it looks very high level for him, so they may watch these videos online, so that they should be on the same level. And also I will also refer you, okay, because I will be here very fast, because it's a graduate course, and I am not supposed to teach you the contents of the undergrad. Okay, so there are like 34 lectures of embedded systems. So if you want to like refer to these in details, so you can go there. Okay, and this is not a traditional graduate course that I will not follow any book. Whatever in the class, I will teach you different research papers, like how to do research. Because my objective is to prepare you for the research. My objective is not to teach you a book. So the contents, if you ask me about the content is not defined, and the content changes every year. Okay, so whenever if you want to have some basic concepts. For basic concept, please refer to these YouTube videos. Okay. Lal said, can you please create a group of all the students? So okay. I will also share all of these relevant material on the personal group. Okay. Now I'm starting with a very simple memory. Okay. So memory. What's the purpose of memory?
Store data.
Store what kind of data?
Temporary data. Immediate data.
Temporary data. There are different type of memory. What type of memories are available?
Cache, memory, and
Not cache.
RAM, ROM. RAM, ROM.
RAM, ROM. So actually, if you look at different types of memory, so we have different types of memory. SRAM memory, standard random access memory, DRAM memory. Then spin transfer trap, random access memory, rest stack memory. We will study this later in more detail. Phase change memory. So these are different types of technologies of the memories that are available. Now, if you look from the architecture perspective, so a memory is a storage device. It can store the data. What kind of data? It can store instructions. It can store the data. Now, when I refer to this C is equal to A plus B, how did we transform this instruction into 4 instructions? What are these instructions? Load, R1, address of A, load, R2, address of B, add, R3, R2 and R1, and then store address of C and R3. So these were 4 instructions. If you look at these instructions, so these instructions has some instruction set encoding. Now let's assume that a microprocessor supports some opcodes. Like let's assume opcode is 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and so on. And it can only support 16 operations. The opcode of the add is 0, 0, 0, and let's assume the opcode of the subtract is SUB. And the type of the instruction that we are supporting is add. This type of instruction is called as R type instruction. And let's assume a scenario in the microprocessor there are 16 registers starting from R0, R1 up to R15. So if you look at the instruction set encoding, let's assume I am like giving an static example of a very simple instruction. So let's assume this is an opcode RD, RS1 and RS2. What does RD stand for? Destination register. What does RS1 stand for?
Source 1.
Source 1 and source 2. So now this is an operation. I told you. Okay. C is equal to A plus B. This is an operation. This is destination. This is source 1. And this one is source 2. And this plus is operation. And operation is determined by which field of the instruction? Opcode field of the instruction. So if we want to have the instruction set encoding of this instruction, so the opcode for add is 0, 0, 0, 0. What is your destination register? R3. What should be its code? 0, 0, 1, 1. R3. Then R2. 0, 0, 1, 0. And then R1. 0, 0, 0. So now let's assume that the contents of this instruction is 0, 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1 and 0, 1, 0, 1. What does it imply?
Subtraction.
It is a subtract instruction. Then destination is R12. If you, I think it's R12 and then R3 and then R5.
Yes.
So actually, what's a memory? Memory is storing the instructions, and actually it is storing the opcode of the complete instruction. And what this opcode contains, this complete encoding contains that how many operations the microprocessor can support. So let's assume if the size of the opcode is 4-bit, it means that microprocessor can now support maximum of 16 instructions. If the opcode is 5 bits,
2 की power
maximum of 32 instructions. If the output is 6 bits, maximum of 64 instructions, and so forth, so on. The same is true for the RD field and RS1 and RS2. So let's assume if the microprocessor, the number of registers that are available in the microprocessor are 32, so we need 5 bits for the RD field, 5 bits for the RS1 field, and 5 bits for RS2 field. So if we increase the number of registers, so the size of the bits that is required for that encoding increases. So this is a very simple example.
Sir, machine code.
This is machine code. This is machine code. Actually, if you look at now, there are different levels of abstraction. High level of abstraction is your C. Then another level of abstraction is assembly code, and this is another level of abstraction that is called as the machine code. And actually, if you look at this program is actually stored in memory. So memory is a very logical structure. So if you look at memory will store 2 for n locations. Memory will store how many? 2 for n location, each of w bits. Logically, memory stores data. It's very important that we should know the representation of the data.